Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to start a new topic of discussion which is on frequency modulation. Okay, so this video in fact is actually an improvised one. Once again, thank you so much for your valuable input and also suggestion. Okay, I have decided to redo this video in order to better meet your objective. The objective of this video is to do a quick introduction. What is frequency modulation? Then I will explain the frequency modulation concept. So basically, this will be the objective of this video. This will be the part 1 series discussion on frequency modulation. So guys, if you're keen to know more about frequency modulation, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on frequency modulation. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me your question through the comment. Before I continue, okay, I'd like to urge you guys to help this channel by pressing the like button. When more you guys actually help to press the like button, this video will have a better chances to reach out to a larger audience. So guys, give me a few seconds. Help me press the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Before we move into frequency modulation concept, let's quickly understand what is modulation. What is modulation concept? Okay, so a signal, basically there can be various forms. For example, the sound wave that we actually produce when we actually shout. Okay, so basically this shout can only be heard up to a certain distance. However, for the same wave, which is the shout, to travel over a long distance, okay, a technique is actually required. A technique to enhance the signal strength without changing the original message is basically required. So in order to establish reliable communication, firstly, we need the assist of a higher frequency signal that actually also require that we preserve the original characteristics of the message signal. If the message signal characteristics change, the information also will be so-called affected. So hence, therefore, maintaining the integrity of the message is essential. A high frequency signal can travel long distance. Okay, so I'm actually correct, but let me explain. You guys probably understand that high frequency actually can have short distance, while low frequency actually can have long distance. Okay, so this is because of path loss. So path loss actually indicate that for low frequency, they can actually travel a longer distance, but for high frequency, they can actually travel a shorter distance. But for this case here, what I like to mention is the high frequency signal, basically they can travel long distance because they have minimum interference from external disturbance, okay, like noise. Therefore, from here you can see that noise can be easily coupled into low frequency signal. It may be a little bit challenge for noise to couple into high frequency signal. So hence, because of this, okay, we actually want to do some form of modulation to move the frequency from low to high so that they have minimum interference from external disturbance. Okay, so this type of signal, which is high frequency, is actually called a carrier signal. Okay, the process of combining the message signal together with the carrier signal is actually called modulation. So in simple word, the definition of modulation is to combine the message with another high frequency signal. So this is the process that we call modulation. There are many types of modulations, depend upon the modulation techniques that you actually want to use. Okay, so in short, they are actually classified as shown over here. Okay, so there are many two types of modulation. One we call the continuous wave modulation. The other one we call a pulse modulation. What is actually a continuous wave modulation? Okay, so from the name imply, you know that this is actually analog in a certain sense here. So basically for continuous wave modulation, the carrier need to be analog. Okay, so as for pulse modulation, the carrier actually need to be in a digital form. So this is why they are called a pulse modulation. So under this continuous wave modulation, you can see that they subdivided into amplitude modulation and also angle modulation. So at this angle modulation, it even subdivided into frequency modulation and also phase modulation. This video, I'm going to concentrate on frequency modulation. So basically, frequency modulation is actually under this angle modulation with a analog modulation. Let's move on to the pulse modulation. So under this pulse modulation, you have two forms. Again, for digital modulation and also the analog modulation. As for the digital modulation, we have this PCM, pulse code modulation. Okay, so later on, you will probably see that they actually improvise and become delta modulation. We are going to do a visit, okay, on the next slides. As for analog modulation, under the pulse modulation, we have PAM, PWM, and also PPM. Basically, this will be the amplitude, this will be the width, this will be the position of the pulse. Okay, so again, all this we are going to revisit on the next slides. This video, again, I like to emphasize that we are going to concentrate on this continuous wave modulation. Okay, so in continuous wave modulation, okay, a high frequency sine wave is used as a carrier. This is further divided into amplitude modulation and also angle modulation, which consists of frequency modulation and also phase modulation. I will take some time to explain this pulse modulation. Okay, so later on my series discussion, I will also do some discussion on pulse modulation. But over now, I just give you some idea what is actually pulse modulation. Okay, so in pulse modulation, a periodic sequence of rectangular pulse is used as a carrier. Okay, so from this word, you know that the carrier is actually a digital signal because they're having a periodic sequence of rectangular pulse, which means that a sequence of 1 and 0. Okay, so this is further divided into analog and digital modulation. Okay, so in analog modulation, okay, if the amplitude, the duration, or the position of the pulse actually varies according to the instantaneous value of the baseband modulating signal. So it is about the same as what we have in terms of amplitude, frequency, and phase modulation. Over here, for this pulse modulation under analog modulation here, okay, we can modify the amplitude, we can also modify the duration, or maybe the position of the pulse in order to represent different value of the amplitude of the modulating signal. So basically, this technique is actually called pulse amplitude modulation. Okay, for the amplitude, pulse amplitude modulation, which is known as PAM. We also have pulse duration modulation or pulse width modulation, as illustrated here. Okay, last but not least, under the position will be pulse position modulation. Okay, so in digital modulation, the modulation techniques is actually called this PCM, pulse code modulation. Okay, where the analog signal is converted into a digital form consists of 1 and 0. Basically, in nature, the signal is actually all analog. So basically, under this PCM, we actually convert them into either 1 or 0. Okay, so since this result is a code pulse train, okay, so therefore this technique is actually called PCM. Okay, so PCM is further developed into delta modulation. So in short, PCM is actually a techniques that actually convert analog signal into digital form. Okay, so the modulation, okay, basically will be the process of varying the carrier signal in according to the message. Okay, so in short, this is what I mentioned earlier on. Modulation is basically combine the modulating signal together with the higher frequency, which is known as the carrier signal. So basically over here, so I would like to focus on these slides here. Basically, let's do a very simple definition of modulation first. So under this type of modulation, we actually have two types. One is under the analog modulation, another one will be digital modulation. Under the analog modulation, we have this amplitude modulation. So under this analog modulation, we have another one which is called the angle modulation, which consists of frequency modulation and also phase modulation. As for digital modulation, okay, basically we have this ASK, amplitude shift keying, FSK, frequency shift keying, and PSK, phase shift keying. So early part of my discussion under modulation, I will basically discuss all the modulation that is shown over here. Later on, okay, I will further discuss on the modulation that is actually shown over here. But for now, I like to discuss on the types of modulation that fall into this diagram for a start. There are two types of angle modulation, as I mentioned earlier on. One will be frequency modulation, another one will be phase modulation. Okay, so what is actually frequency modulation? Okay, so under this frequency modulation, the frequency of the carrier actually change according to the amplitude of the modulating signal. So in short, the carrier, okay, basically the frequency will change according to the amplitude of the modulating signal. Hence, because of this, the peak amplitude of the carrier, which is the amplitude, they remain unchanged. Regardless what is the message of the modulating signal, the peak value of the carrier remains unchanged. Only the frequency change according to the amplitude of the modulating signal. In phase modulation, they are actually quite similar with frequency modulation. But for phase modulation, the phase angle of the carrier will change according to the amplitude of the modulating signal. Very similar with frequency modulation. Now, only the phase will change according to the amplitude of the modulating signal. Again, like to re-emphasize this also, the peak amplitude, okay, of the carrier remain unchanged. Okay, both FM and PM, they are actually collectively known as angle modulation, as mentioned earlier on, because the peak amplitude of the carrier is fixed, but the frequency or the phase angle actually change respectively with the modulating signal. Next, okay, the figure below shows the effect of frequency modulation and also phase modulation. Okay, basically, the modulating signal is just a sinusoidal so-called signal, basically with one frequency. Okay, so basically, let's do this here. So this is a modulating signal. This is the signal that we actually want to send to a recipient. So most of the time for modulating signal, they actually has a low frequency. As for modulating signal, they actually has various names. For example, they also know as baseband signal, intelligent signal. Basically, they are the same. So for me, let's make it easier. Let's call this modulating signal. So modulating signal typically has a low frequency, as you can see from here. So next will be the unmodulated carrier signal. Unmodulated carrier signal means that they does not carry any message yet. Typically for carrier signal, they have a higher frequency as compared to the modulating signal. And if you compare this, okay, you know that this carrier actually has a higher frequency as compared to the modulating signal. So next, when they actually combine, when the modulating signal actually combine with the carrier. So under frequency modulation, basically what happened, as I illustrated earlier on, okay, the frequency, okay, of the frequency modulated signal actually change. From here, you can see that they actually change. Basically over here, okay, when they are actually at the maximum amplitude of the modulating signal here, you can see that in general, they have the highest frequency while they are at the lowest, okay, amplitude of the modulating signal over here. You come over here, you can see that typically they has the lowest frequency. So basically, in short, based on the amplitude of the modulating signal, I vary the frequency, and hence because of this, you are able to replot the original modulating signal. So basically, this will be frequency modulated signal. It is the same case for phase modulated signal, okay, but I will emphasize this when we actually discuss on phase modulated signal. Let's move on. The frequency modulation is actually a method of encoding information in a carrier wave by varying its frequency while keeping its amplitude constant. Okay, so this is widely used in FM radio broadcast, telecommunication, and also signal processing. Okay, so let's come to the key feature of frequency modulation. Okay, one thing is called the frequency variation, okay, which is the delta F. What is actually the delta F? This is actually the frequency of the carrier wave change based on the amplitude of the modulating signal. Okay, so later on I will so-called emphasize this again, but this frequency deviation is basically based on the amplitude of the modulating signal. When we actually has a higher amplitude of the modulating signal, then we will have a higher frequency variation. When we actually has a lower so-called amplitude, then we actually has a lower frequency variation. Okay, so again, I will emphasize on this again. Next, on the amplitude consistency. Okay, so unlike amplitude modulation, for amplitude modulation, the modulating signal actually appeared at the envelope of the amplitude modulated signal. But for this case here, for frequency modulation, the amplitude is constant. They remain unchanged. So therefore, the key purpose is we want to reduce noise. And also because of this, we actually will be able to improve the signal clarity. Okay, bandwidth usage. Okay, so basically this will be the disadvantage of frequency modulation. FM actually typically use more bandwidth than AM, which means that we need to have more resource in order to send the same message. However, FM actually provide better sound quality, and also they are highly resistant as compared to AM against interference. Okay, so this is a diagram here to show how does frequency modulation. Okay, so basically it's a very simple concept here. So this is what I mentioned earlier on. This is the information that I actually want to send to the recipient. So therefore, we call this as a modulating signal, baseband signal, or maybe intelligent signal. How to describe this signal? So basically, you can see that this is actually sine or cosine wave. Okay, so basically, this is the amplitude, okay, of the signal here. So as illustrated over here, this FM is actually the frequency of the modulating signal. So in short, we can actually describe this in time domain, okay, with this equation over here. So next will be on the unmodulated carrier signal. Okay, so basically this carrier does not carry any information yet. So therefore, you can see that they actually has a constant frequency. So from here again, how to describe this waveform here? Okay, so basically this will be the amplitude of the carrier, and we also have this carrier frequency over here. So basically, in short, this is how we describe the carrier signal in a time domain with this equation here. So modulation is basically the process of putting these two together into one. Okay, so basically this is what I mean by frequency modulation. When we actually do frequency modulation, keep this in mind, we only change the frequency. So from this equation here, you can see that the amplitude remain constant. It will be having the same amplitude as the carrier, as you can see from here. They will have the same amplitude, but the frequency need to change. Okay, so this is the frequency. How does the frequency change? The frequency needs to change to so-called the amplitude of the modulating signal. So from here, you actually can see that this is actually the modulation index followed by the signal of the modulating signal. Okay, but don't worry, on my next video, I actually will prove this equation. But over here, you can see that I actually express the modulated signal in this equation, which means that I actually combine the modulating signal together with the carrier to form the frequency modulated signal as shown over here. Okay, so basically this is what I mentioned here. Okay, so basically in general, this will be the mathematical representation for frequency modulation. Let's move on. Okay, so like to so-called denote some of the key parameters here. So I mentioned that this is actually the carrier amplitude. This is actually the carrier frequency. This is actually the modulating frequency. And this is what we know as modulation index. Okay, so later on we will take a look on this modulation index. Let's move on. Okay, so this diagram here, I actually present two diagrams so that you can see the key distinct difference between these two. Okay, so firstly, let's take a look on the red color line. So this is what we call the modulating signal. This is the signal that we actually want to send to the recipient. This is the original message, which is also known as baseband signal or intelligent signal. The blue color is actually the unmodulated carrier signal. Okay, so basically they does not carry any information currently, and hence because of this, you can see that the frequency of the carrier is still constant. However, for this case here, you can see that the carrier actually now become a modulated carrier signal, which means that now they actually carry the message. Like I mentioned earlier on, this is actually the modulating signal. When the amplitude of the modulating signal is at the highest, you can see that over here, they actually has the highest frequency. As when they actually reduce over here, when they actually appear at the lowest, okay, the amplitude of the modulating signal at the lowest, you can see that the frequency of the carrier is also the lowest. So basically from here, once you see high frequency, which means higher, once you see the lower frequency, which means lower. So hence, because of this, I will be able to be successfully plot the modulating signal. Okay, so basically this is what frequency modulation concept is about. By altering the frequency of the carrier, I actually can represent the amplitude of the modulating signal. Okay, let's move on. Okay, let me give you another example so as to be clear. Okay, so basically you probably have seen this diagram here. Okay, so basically this is the carrier frequency. Okay, so basically this is what we call the frequency deviation. Okay, so remember I told you that this actually will depend on the amplitude, okay, of the modulating signal. So basically how far they swing will be basically based on this here. So this will be so-called FC plus frequency deviation. On the other side will be FC minus frequency deviation here. So this is the case here. So as I explained earlier on, okay, when the modulating signal is at the lowest amplitude, the modulated carrier has the lowest instantaneous frequency. While the EM is at the highest amplitude, the modulated carrier has the highest instantaneous frequency. Let's take a look on this diagram in order to understand better. Okay, so I have highlight, okay, three important regions. One is the yellow, one is the blue, another one will be the red. Okay, so let's understand this better. Let's say I start out from this point here. Okay, so how I plot the modulating signal, since this is actually exactly at the 0 point here, okay, so therefore the frequency will be appearing at the carrier frequency. Can you imagine this? This will appear at the carrier frequency. So now the modulating signal actually start to drop. As you can see from here, they start to drop, and finally it reach over here. So will be the lowest point, okay, of the amplitude of the modulating signal. So basically, like the definition over here, this will be the lowest amplitude. So hence, the modulated carrier will have the lowest instantaneous frequency over here. So basically, just imagine when the modulating signal shift from the yellow line through the blue line, you can imagine that this arrow also start to shift to the left. Can you see here? Can you imagine this? They will start from this carrier, they will start to shift to the left, and finally, when they reach this point, they will be exactly at this point. So basically, from here, I know that the signal will be beginning from the 0 point and they start to decay because I can see that the things start to shift to the left over here. So next, they start to increase. Can you see from here? They start to increase. So now we are actually at this point here. So I can see that because to represent this increase all the way to here, you can see that this line again will be shifting to the right. And finally, they will be stopping over here. This actually indicate how we actually represent from this point, okay, all the way back to this point here. So basically, they will shift from the left all the way to the center again. So now what happened here is basically you can see from here, the thing further increase all the way to the maximum point of the modulating signal, okay, the amplitude of the modulating signal, which means that they will be actually a bit over here. So what happened here is basically they will be at the middle over here, and you can see that the arrow actually start to shift to the right. And basically from there, I will know that it will be from 0 point, it will be increased. I will draw until all the way to the maximum. Okay, so basically this is how frequency modulation concept is about. Based on the amplitude of the modulating signal, I actually will show the frequency. When the so-called uh, when the amplitude of the modulating signal is at the least, okay, I actually will have the lowest instantaneous frequency. So basically this in blue, I will appear here. When the modulating signal has the highest amplitude, okay, so which means that I actually has the highest instantaneous frequency, I will appear over here. Okay, when my modulating signal cross at the 0 point, okay, it will be exactly at the carrier frequency. So basically from here, you can see that by moving the so-called the arrow, okay, either to the left or to the right, basically will indicate whether is it a rising edge or a falling edge. And this is how we can represent the modulating signal. Okay, so over here, you can also clearly see that this signal used to be a low frequency, but once I put into carrier, okay, the frequency can be increased. Remember, as I mentioned earlier on, modulating signal has a lower frequency as compared to the carrier. And hence, because of this, I actually successfully moved the frequency from a lower frequency to a higher frequency. Okay, so basically this will give you the concept of frequency modulation. Okay, so just make it easier. Okay, so what happened here is the amplitude, okay, of the modulating signal double. Let's say we are able to do double. So you can imagine that this thing actually will double. So instead of plus 1 delta F, it will be plus 2 delta F, which means that they actually will travel further away to represent the amplitude of the modulating signal. Okay, so basically with this, I hope it's more clear. So basically, in short, this so-called deviation frequency actually depend on the amplitude of the modulating signal. Okay, so before I continue, okay, I'd like to urge you guys to help me by like this video. Okay, so if you have learned something from this video, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let me continue. Okay, so this is what I mentioned earlier on. How does frequency modulation work? Okay, firstly, the frequency of the carrier wave change according with the input signal, which is the message. The frequency, as I mentioned earlier on, they will either shift to the right or shift to the left, depend on the amplitude of the modulating signal. A high input signal, which means that a high amplitude modulating signal will basically increase the frequency deviation. A low input signal will basically reduce the frequency modulation. Okay, so basically this is what I mean. So this is with a high so-called amplitude of the modulating signal. This is actually the lowest point of the amplitude of the modulating signal. Okay, but over here you can see that the amplitudes remain unchanged. You can see that they actually has the same so-called amplitude of the carrier. Okay, so because of this make FM more resistant to noise and interference as compared to amplitude modulation. Okay, coming to my last slides, let me quickly discuss the advantages of FM over AM. Okay, so we know that they actually has a better noise immunity. Okay, so AM signal actually suffer from atmosphere noise and electrical interference, whereas FM is less affected. Okay, so we know that FM has a better noise immunity. We will discuss on this more, okay, on my later series discussion on frequency modulation. FM also has a higher so-called better sound quality as compared to AM. Okay, because FM actually provide a very high fidelity audio transmission. Okay, so therefore they make it ideal for music and voice communication. So therefore nowadays, I would say that probably we still have FM broadcast. We already face up the AM broadcast because AM broadcast actually will be very subjective to noise. Okay, because FM also has a constant amplitude. Okay, since FM does not depend on amplitude, hence the signal strength can be remain stable. Okay, so as compared to AM, the amplitude actually varies. So when the amplitude become low, it may be very vulnerable to noise. But for FM, the signal strength actually remain the same because the amplitude is still the same. Okay, so it's more power efficient when we actually use FM. Okay, because the power is distributed more evenly in FM as compared to AM. However, saying so many advantages of FM also has the disadvantage. For example, okay, FM actually under the ideal world, they require infinite bandwidth to send. So hence, okay, even we constrain them, it also require much larger bandwidth as compared to AM, which means that we need to use more resource as compared to the AM. It also has more complex receiver circuit as compared to AM. Okay, however, okay, the disadvantage of our FM can be ignored. The advantage simply outweigh the disadvantage, and because of this, frequency modulation is widely used. Okay, so I hope you have a better idea on frequency modulation. Okay, so with this, I'd like to end my discussion. Okay, please help to like and subscribe. Once again, thank you so much for your strong support. I hope to see you guys soon. Bye for now. Thank you.